Hi there. In this video, we're going to talk about the standard normal model, which is labeled Z, and we're going to talk about z-scores and learn what they are and how to calculate them. Okay, so first of all, the standard normal model, we use this when we want to compare unlike events. So even if two events are quite different, we can still compare them using the standard deviation as a ruler. Let me draw just a little number line here, and I'm going to put 0 in the middle. And this is if something lands right on the mean, we're going to say that is right at 0. And then we're going to label 1, 2, 3 for 3 standard deviations to the right, and -1, -2, -3 for 3 standard deviations to the left. So we could say, so this 1 is like 1 standard deviation above the mean. I'm abbreviating here because there's not a lot of space. And -1 is 1 standard deviation below the mean. Okay, so think of this standard deviation like we saw how we label 3 on each side. Think of the standard deviation as a ruler, and what we're going to be calculating is for a certain event, how many standard deviations is it away from the mean? If it's positive, it's going to be above the mean. If it's negative, that tells us it's below the mean or below average. Okay, so we're back to our rainfall example. Hopefully you're not getting too tired of this one. Annual rainfall for Portland is 40 inches per year with a standard deviation of 8 inches. And now we want to compare that with wind in Chicago, the windy city. So let's compare annual rainfall in Portland with the wind speed in Chicago. Now this says that it has an average of 10 miles per hour with a standard deviation of 2 miles per hour. So suppose that one year in Portland, the annual rainfall was only 24 inches, and Chicago's average wind speed was 13 miles per hour. Which one of these events was more extraordinary? Okay, so think extraordinary is unusual. So we're going to be looking for which one is furthest from the mean. Okay, so we have this formula for a z-score. What we do is we take whatever value we're given and we subtract the mean. So that tells us how far away from the mean a particular value is. And then when we divide by the standard deviation, that tells us how many standard deviations away that is. Okay, so let me write that down here. The numerator is the distance away from the mean, and then when we divide, this dividing by sigma tells us how many standard deviations that distance is. Okay, so let's do this example, so make it even more clear and concrete. Okay, so z-score for 24 inches of rain in Portland. We take our x value first, which is 24, and we subtract our mean. So our mean is 40. And we divide by our standard deviation of 8, which we are very used to know those numbers by now. Okay, 24 minus 40. Now I need to hit enter before I divide or use parentheses. Divided by 8 is -2. Now the units on the z-score is standard deviations. So this is -2 standard deviations. Or I could say, let me move this up. I could say 24 inches of rainfall is 2 standard deviations below the mean. Okay, I wouldn't say -2 below because that's a double negative. The negative means below. Okay, now remember when we drew this out, we can actually see that 24 is exactly 2 standard deviations below. Pretty cool, huh? But not every z-score will be right on one of the even standard deviations. So let's do the wind speed for Chicago. That was 13 miles per hour. Our mean is 10. And our standard deviation is 2 miles per hour. 13 minus 10, so that's going to be 3 above this time. That's why the order of the subtraction is really important, because it tells you positive is above and negative is below. So 3 divided by 2 is 1.5 standard deviations. Okay, or we can say that 13 miles per hour is 1.5 standard deviations above the mean. So really what we're doing is we're comparing this year in wind to all the years of wind in Chicago versus this year in rain to all the years of rain in Portland. So we're comparing apples to oranges, but we're comparing all the apples with the apples and all the oranges with the oranges. And so if we look at, let's go ahead and draw out our standard normal model underneath here. When we draw, just like we're used to drawing our normal model, but the mean is always 0, because when we subtract the mean, that puts the mean at 0, and we go 1, 2, 3, 1, 2, 3, -1, -2, and -3. So the standard normal model, we use the letter Z to distinguish it. So we use X for any regular normal model, but the standard normal is used with Z, is denoted by Z, and that's always normal 0, 1. So the mean is always 0, the standard deviation is 1. You may have noticed when you go into GeoGebra that's the default. I don't know if it is, I think it is also for online stat book, it's the default, and that's because it's used pretty commonly with z-scores. Okay, so that is our Z, and then let's notice where Portland and Chicago were on here. So Chicago was 1.5. I'll put a C for Chicago. And then Portland was at -2. So there's Portland. So which one was more unusual? One was above average, one was below average, but Portland was actually further away from the mean, or more towards the tail. So the wind in Portland was more unusual or more extraordinary. Did I say wind in Portland? The rain in Portland was more extraordinary. Okay, so sometimes you'll be asked to calculate a z-score for a single value, and sometimes you'll be comparing two, just like we did here. Okay, now our next example we're just going to practice a little bit more, and I want to talk about a few more things, and then we're going to calculate this with online stat book. Okay, so when we standardize into z-scores, think about we're transforming our normal curve from mu and sigma into 0 and 1. So it doesn't change the shape of the distribution. And it just changes the center to be 0, and then it changes the spread to be 1. Okay, so the normal distribution model is the one that models the continuous distribution of populations. Okay, I think we've already talked about a lot of this already. Normal models are only appropriate for distributions that are symmetric and unimodal. The standard normal model has a mean of 0 and standard deviation of 1. And like I wrote on the last page, we say z is distributed as normal with 0, 1. And here's the z-score formula one more time. Okay, so 0, 1, 2, 3, negative 1, negative 2, negative 3. So that's our standard normal. It doesn't really, I don't know what we would label this scale with. So let's go ahead and find a couple probabilities. Find the probability that z is less than 1.5. So what this is saying is for any distribution, what's the probability that a value is less than 1.5 standard deviations from its mean? Okay, probability I added the word above in there because that's important, because you could think 1.5 below or 1.5 above. What's the probability that's less than 1.5 standard deviations above its mean? So let's go to online stat book. And I'm going back to the one where we are finding the probability or area. And now I need to put in my new mean of 0 and standard deviation of 1, and I want below, you can see we've got the appropriate scale there, below 1.5. Okay, so it should be a fairly high probability. It's 0.9332. Okay, so 0.9332. The next one is find the probability that a z-score is between negative 0.3 and 0.5. So from negative 0.3 or from 0.3 standard deviations below the mean to half a standard deviation above the mean. So we're going to go to between this time and do negative 0.3 up to 0.5. Just double check my picture, looks good. 0.3094. Okay, and here's one more example to try. If you want to try it out on your own, feel free to pause the video and then just use it to check your work. An incoming freshman took her college's placement exams in French and mathematics. In French, she scored 82 and math 86. The overall results on the French exam had a mean of 72 points and a standard deviation of 8 points, while the mean math score was 68 points with a standard deviation of 12 points. On which exam did she do better compared with other freshmen? Okay, so let's try this out. So first I'm going to label each of my distributions because I find it helpful to pull out the mean and the standard deviation. So X, well, actually I should use French and math. That will be a little easier. So let's say French, because we don't have to use X, we can use a different letter. French is distributed as a normal distribution. The overall French exam had a mean of 72 and a standard deviation of 8. Okay, and then the math exam is normally distributed with a standard mean is 68 and the standard deviation is 12. Or you could do x1 and x2 if you prefer that. Okay, so now we're trying to find the z-score of each one. So I'm going to do z equals, in French she scored 82. So 82 minus 72 over 8. And then in math, oops, wrong color. In math she scored 86. So this z-score will be 86 minus 68 over 12. Okay, so let's calculate both of those. (82 minus 72 is 10 divided by 8, 1.25 standard deviations. And for math, 86 minus 68 is 18 divided by 12 is 1.5. Okay, now let's review this question again. On which exam did she do better compared with the other freshmen? So this is a different question than the other one we had. The other one was which one was more extreme or unusual. This one is, and which one did she do better? So this time we'll be looking for which one is higher than the other. So which z-score is higher? Okay, so compared, French compared to French, she scored 1 1/4 standard deviations above average, above the mean. And in math, she scored 1.5 standard deviations above the mean. So in math, she scored better compared with other freshmen. I think it should be freshmen. Okay. All right. Try this out, and I'll see you in the next video.